So this is an outlier. An outlier is the data that is really extreme when you compare it to the rest of the data. You know, it really stands out in that, let me just see something, in that it's very far to the left, but it's very far to the right when you graph it in a history, when you graph it. So it really stands out in that it's either very small or far to the left when compared with the rest of the values, or it's very large and to the right when it's compared with the rest of the values. And you probably can guess this, although I wrote it on the slide already. Generally, it's easier to find outliers when the data is graphed. I mean, you probably could find it from a frequency table or just looking at the data itself. That's possible. For the most part, though, you want to graph the data. I mean, for instance, here, from the data here, you might be able to see that, yeah, 1 is an outlier. It's a lot smaller than these other values. And you can see 1 is also very far from the rest of the data. The rest of the data is over here, but there's a value of 1 over here, right? 1 is here. So we can see that 1 looks like to be one looks like is an outlier. That's what we get here. So we have an outlier here. Again, you know, it's easier to graph to see where the outliers are. It's kind of like that saying, I guess, a picture is worth 1,000 words. All right. So that's what an outlier is. There we go. All right, so again, I really don't want to go beyond what outliers are, how outliers are treated in the book. So let me move on to that. So before, when I was talking about, you know, distributions, I said, imagine folding along the center, right? You know, I kind of said that over here, folding along the center. But you have to ask, wait a minute, what exactly is the center? You know, we're in the mathematics world, for instance. We have to be precise. You know, explicit, precise. So what do you mean when we say center, right? Well, there's actually different ways to measure what we think the center should be. When we say center, what we could mean is the mean. That's one thing we could mean. The mean of a data set is just the average. In a traditional sense, you know, in other words, you add up the data values and divide by the number of them. Add up the data values and divide by the number of them. You know, when you hear people say, on average, this happens, yeah, this is what they mean. For instance, if we have this, right, we want to get the mean of this, right? We just add up the data values. We divide by the number of values, and that's what I'm doing here. Okay? All right. So that's what we get here. Okay. So in this case, what do we get? We get 349 divided by 8, which is 43.625. That's what outlier. So that's what mean is. Okay, well, here are some other examples. You know, let's say I went to 5 different stores in Oneonta and I recorded the price of peanut butter. Why did I do this? I don't know, for fun. But let's say these are the prices I found. And I want to figure out what the mean price is. Well, again, you know, we're taking an average, in other words. We add up and divide by the number of data values. Of course, we're assuming we have quantitative data. I mean, if these were colors like red, orange, yellow, green, blue, you know, this would not make sense. So we're working with quantitative data. So we're adding up these numbers, and we're dividing by how many there are. Like so. And so when we do that, we get this, $17.91 divided by 5, and that's $3.58. So this is what we get. This is our mean price. Now, this is just saying also that, when I actually did this calculation, I actually got this. Since this was currency, I rounded to 2 decimal places. All right, that's cool. Now notice here the data was laid out, explicit. Here we have a frequency table. And maybe not from here, but you might be thinking that, well, normally I would list all the data. But you really don't want to do that, though, because that can be very cumbersome. But we don't have to, as I'm showing here. If we're going to get the mean, right, well, we want to add up all the data values. So if we were to list it, we would have 12 listed 4 times. 14 would be listed once, right? And we would have to add up all the data values. But instead of listing 12 4 times and adding those, we could just do 12 times 4. That takes care of the 12s. 14, we just have 14 in there, which is 14 times 1. 14 is listed once. 7, we could list it 5 times, add up the results. We don't have to. We just do 7 times 5. Same thing with 5. You can list 5 6 times, and then just add up the results. We don't have to. We could just multiply. That's what I'm doing here. So for each of those products, I'm going to add, right? That's the sum of the data values, which in this case is 127. Now, how many data values are there? Well, that's the frequency. We add up the frequencies. That's the number of data values, which in this case is 16. And again, we do the quotient. We add, and then we add up the data values divided by the total number of data values, right? And we get our mean. Okay, so again, we don't have to list these data values, right? Instead, we could just multiply by the corresponding frequency. We add, right? And we get the sum of the data values. The number of them, that's what the frequency is. So we can add up the frequencies as well and divide. Okay, let me do another one. So here, let's say this is another one, right? And we want to get the mean. Well, we could list, each data value, exam scores in this case. We could list 20, 25 times, and list 16, 30 times, and so on. But we don't have to. I mean, if you list 20, 25 times and add up the results, that's the same as doing 20 times 25, which is down here. And then doing 16 times 30. If you list 16 30 times and add, you would get 16 times 30. Same thing. And so we have also 18 times 35, 19 times 40. And again, this is the sum of the data values here. And then we divide by the sum of the frequencies, as you can see. Right? The frequency is how many data values there are. So what do? We add. As you can see, we're adding the numerator and denominator. And then we divide, and we get this. So again, this is what we get. This is how we get the mean. I mean, you could list all the data values, but I'm showing you here that, well, you don't have to. That's Okay, that's fun. Any questions on this? Remember, I can't see the chat, so use the hand raise feature if you have a question. Okay, so here's what I want everyone to try. Find the mean of these exam scores here. So I want everyone to try that for about 3 minutes. Let me just stop the recording.